I hope the screen is visible to everyone.
Yes, ma'am.
Okay,
Yes,
fine.
ma'am.
Yes, ma'am.
Before I start with this today's experiment, is there any doubt in the last experiment? We shared one video with you all, hydrolysis of ester.
Yes,
Do
ma'am.
you have any doubt regarding that
Yes,
experiment?
ma'am.
Yeah, tell me first.
No, ma'am,
If
no
you
doubt.
no doubt, okay, fine, fine. Then we can start directly with the today's experiment if there is no doubt.
Yes, ma'am.
Okay. So today we are going to talk about the Osazone formation. Okay. So before I start with the Osazone formation, let us first understand the background of this reaction, where this derivatives is used, and you can say what is the importance of that. So in the case of Osazone formation, this is something related to the term that is carbohydrates. So everyone knows the carbohydrate, they are the sugars, starches, the fiber material, which is found in fruits, grain, vegetables. They are the main ingredient of the energy source and something which we are getting after digestion, and it is broken down into glucose. This glucose is coming into your bloodstream, and whereas it is converted into the adenosine triphosphate, that is ATP molecule, by the complex series of reactions, we call them as cellular respiration. So through this, the glucose is converted into the ATP, and the ATP is used by all the cells so as to perform their regular metabolic task. Excess of glucose, if you have in the body, that is stored in the body in the form of glycogen, and this is generally found in liver and the muscles. Okay, so this is the carbohydrate background. We know that the carbohydrates are very important for us in the you can say in energy point of view. Now what are the functionally, what are the carbohydrates? They are the compounds containing the carbon, hydrogen and oxygen. Now, when I'm talking about the sugars, we have classified them into different types. You have studied a different classification of the carbohydrates in your 12th standard. Like they are classified as simple and complex sugars. In simple, we have the monosaccharides and oligosaccharides. In complex, we have the polysaccharides. Or we can also classify them as sugars and non-sugars, but I'm going to specially talk about one classification here, that is nothing but reducing sugar and non-reducing sugar. Now, what is this reducing sugar and non-reducing sugar? Carbohydrates, if you look at the functional group wise, they are either aldoses or they are ketoses, right? So they have the aldehyde as a functional group or the keto as a functional group. If you look at the structure of the glucose, everyone knows that the glucose, uh, it is a kind of like aldoses containing 6 carbon atoms. So we call it as aldohexose. This is the open chain structure of the glucose, and we can present in the Haworth projection formula like this. It is present in the closed ring form. But we have to see that the first carbon, if you look at this first carbon in open chain, this is the anomeric carbon. Okay. And if you look at this anomeric carbon in the closed chain form Haworth projection, it is available here, and it is freely available in the closed chain form as well as in the open chain form. So in this case, what we can say, this glucose structure has this aldehyde group or the keto functional group. It is freely available, and since it is freely available, if you it is these functional groups act like a reducing character. If you allow them to react, they will reduce others and themselves will undergo the oxidation process. Okay. If you look at this structure, this is lactose. Look, if you look at the lactose is a combination of two molecules. One is a glucose and one is the galactose. But the linkage of glucose and galactose, if you see, this is 1,4 glycosidic linkage. In this 1,4 glycosidic linkage, still we can see at in this particular ring, this first anomeric carbon is still free, and this is capable of reducing the different reagents, and therefore this kind of sugars we call them as the reducing sugars, in which the aldehyde or the keto functional groups are free and they're free to react. On the other hand, if you look at these sugars, I've given you two examples here. One is a sucrose and one is the maltose. Now, sucrose is a disaccharide, which is a combination of glucose and fructose. If you see here, the glycosidic linkage is formed between the first carbon of the glucose and the second carbon of the fructose. And if you see, for the glucose, its first carbon is the anomeric carbon. And for fructose, your second carbon is the anomeric carbon, right? That is your functional group, keto functional group. Both of them are involved in the glycosidic linkage this time. So they are not freely available to react with the other reagents. So this kind of sugars, we call them as non-reducing sugars. Okay. Even you can see the example of maltose here. There is no free anomeric carbon in this case, and therefore it also comes under category of non-reducing sugars. Okay, so we can classify the carbohydrates into two types, either reducing sugar and the second one is the non-reducing sugar. Reducing sugar are those carbohydrates which have their free aldehyde or keto group. They are free to react. But the non-reducing are those which are not having the free aldehyde or keto group. Okay. Now, come back to the topic of today's practical. This is Osazone formation. Okay, so what is this Osazone? Osazone are the carbohydrate derivatives which are formed by the reducing sugar. Remember this, the reducing sugar which are having that free aldehyde and keto group. They are capable of reacting with the phenyl hydrazine. This is our reagent in the reaction. So it is capable of reacting with the phenyl hydrazine at the boiling temperature, and the derivative which we get by the reaction, that we call it as Osazone derivative. This technique of Osazone formation was discovered by the Emil Fischer. In fact, the Emil Fischer is responsible for the discovery of the phenyl hydrazine also. So he synthesized that phenyl hydrazine, and later on, in the application part, he just found out the different you can say the derivative preparation of the carbohydrate. Now, if you look at this, I have given you here three carbohydrate structures. The first is glucose, second one is fructose, and you can see the third one is the mannose. Okay. Now, if you look at the first compound, glucose, it is having aldehyde as a functional group. The second one is having the keto as a functional group. And over here again, I have a aldehyde as a functional group. So my first compound and my third compound, they are aldoses. While the third, that is second compound which we have taken, that is ketosis, that is fructose. But look at all of them are having 6 carbon atoms. So they are all hexoses, right? But if you look at the configuration at third, fourth, and fifth carbon, look at all the three. This is third, fourth, and fifth carbon. Third, fourth, and fifth carbon. If you look at the configuration, the arrangement of atoms, you can see all the arrangement of that hydroxy group. They are all same. So though the other configuration may be different. If you can see at the second carbon over here, the OH is on right hand side. Over here, it is on left hand side. So that is going to create a difference in the configuration. But if you look at the third, fourth, and fifth carbon, we have all the same configurations. Now, if you look at this, first of all, the glucose on reaction with one equivalent of phenyl hydrazine. Now, you have studied the reactions of aldehyde and ketone. If you see here, hydrogen will be lost from here and oxygen will be lost from here. And I will get formation of phenyl hydrazone at this position. So we are getting formation of glucose phenyl hydrazone. Similarly, if I allow the mannose to react with one equivalent of phenyl hydrazine, here also we are getting the same reaction and we are getting formation of mannose phenyl hydrazone. But both of them further on reaction with two equivalent of phenyl hydrazine end up with the formation of Osazone. And this Osazone have the same structure, that is glucose as well as mannose gives us the formation of same Osazone. Even if you see this fructose on reaction with the three equivalent of phenyl hydrazine, it's ending up with the same Osazone formation. So somewhere this Osazone formation it's utilized in order to find out which are the reducing sugar. That's one of the application. Secondly, we can also find out which sugar is present. because all these Osazone derivatives are a fine crystalline structure, and with the help of this crystal structure analysis, we can find out which sugar is present in the given sample. Okay, so let us exactly find out how we are going to carry out this Osazone formation, exact reaction we are going to talk about it. So what is the reaction? First of all, this is your glucose molecule. This is on reaction with three equivalent of phenyl hydrazine, going to give us the formation of, you can see here, there are two phenyl hydrazone linkage are formed over here. So this is your product Osazone. So glucose has been converted into glucose Osazone with the help of three equivalent of phenyl hydrazine. Now during this reaction, there is a byproduct, that is phenyl aniline and ammonia. Now let us find out exactly how this reaction is going to take place. Let us discuss about the mechanism. Is there any doubt in the reaction part? Have you understood what is Osazone and what is the starting material used for it? One starting material is a
Yes, ma'am.
glucose and the second one is the phenyl
Mhm.
hydrazine. Okay. So let us go for the mechanism part, exactly how this reaction is going to take place. So this is my glucose molecule, right? Now in the glucose molecule, our active functional group is your carbonyl group. So if you look at the carbonyl group, we know that carbon is electropositive and this is electronegative. Now this in
मैम
phenyl hyd, yeah,
मैम रिएक्शन एक बार रिपीट कर सकते हो क्या?
yes, I will see this. Glucose on reaction with three equivalent of phenyl hydrazine. Okay, this is phenyl hydrazine. Hydrazine क्या होता है? Hydrazine is simply this, right? In which one of the proton is being replaced by the phenyl group. So this is phenyl hydrazine. We are using three equivalent of phenyl hydrazine and its reaction is going to give us the formation of Osazone. अब ये Osazone कैसे form हो रहा है? Exactly, I'm going to tell you in the mechanism part. During this reaction, aniline and ammonia, they're the byproducts, and how they are liberated, that we're going to talk in the mechanistic part. Is it fine?
यस मैम.
Okay, so now let us come back to this part. What I said, in the this glucose molecule, we have this first functional group, that is aldehyde functional group. The carbon is electropositive and oxygen is electronegative. Now this nitrogen has lone pair of electrons. So it can share this lone pair of electron with carbon, so that this bond will break and electron will shift to the oxygen. Oxygen originally having two lone pair of electron will have one more lone pair of electron. Okay, so oxygen will carry negative charge and one of this proton from this NH2. Since the nitrogen is forming a new bond with the carbon, this proton will leave from here and it will form a bond with the oxygen. So that's why I will get this. You can see here the new bond is formed between this nitrogen and carbon using that lone pair of electron which was here. Okay, the proton is removed from here and it is shifted to the oxygen. Oxygen is now becoming the hydroxyl group. Okay, but at the same time over here, this proton, whichever is present here, now they will undergo the loss of water molecule. Now OH will be lost from here and H will be lost from here. So कार्बन से OH लॉस हो रहा है और नाइट्रोजन से हाइड्रोजन लॉस हो रहा है. So there is a loss of water molecule and they will form a double bond between each other. So you can see here we have formed the glucose phenyl hydrazone. So this is hydrazone of glucose which is formed at the first carbon atom. Okay, but at the same time this particular rearrangement, this particular molecule, we undergo the tautomerism, and in the tautomerism part what will happen, this particular carbon hydrogen bond will break and this will be shifted here. So as it will be shifted here, the lone pair of electron will be shifted to the nitrogen, and as it will shift to the nitrogen, this particular proton which is left from the molecule, it will shift to the nitrogen. So this double bond will now become single bond. Again I'm repeating, there is a tautomerism part here. So hydrogen will leave and it will return the electron here. So double bond will be formed between these two carbon. So this bond, now double bond will break, lone pair will be shifted to the nitrogen again. Nitrogen will have now lone pair of electron and it will share that lone pair of electron with this proton again. So now what you can see, this proton is left from here, double bond is formed here, this double bond is becoming single bond and proton is given here. Okay, And now this will undergo the further rearrangement. During this reaction, what will happen? See, this is oxygen here. Now proton will leave, proton will give electron to the oxygen, and these electrons will come here to form the double bond. As it will come here, this double bond will be shifted here, and as the double bond shifted here, this nitrogen will leave. And you can see here, this is nothing but, you can see here, this is phenyl NH. This NH is getting the proton. Proton यहाँ से निकल गया. That will be accepted by this, and we'll get the byproduct aniline. So this aniline is formed as a byproduct during this reaction. In short, what has happened? Your second carbon, you can see here the second carbon was secondary alcohol. It has been converted into carbonyl group. So this is the oxidation is taking place in this reaction. As we said, this particular glucose is capable, or this aldehyde group, they are having the capability of reducing others. Themselves, they undergo oxidation process. In fact, your Osazone formation is one of the oxidation process. Okay. So till now, is it clear what is happening? First of all, what I said, the phenyl hydrazine, the lone pair of nitrogen attacking on the electrophilic carbon, they're forming the addition product. This addition product is undergoing the loss of water molecule to give the formation of glucose phenyl hydrazone. The glucose phenyl hydrazone is undergoing the rearrangement, and that is further giving the loss of the aniline from the molecule. अब यहां तक अगर तुम देखोगे तो हमने एक इक्विवेलेंट फिनाइल हाइड्रोजीन को यूज किया है. ओवरऑल रिएक्शन में याद है तो कितने इक्विवेलेंट यूज किए थे हमने? 3 इक्विवेलेंट. तो उसमें से एक यहाँ पे यूज हो गया है. अब हम यूज करेंगे दूसरा फिनाइल हाइड्रोजीन. सेम वी आर एक्सपेक्टिंग इन दिस रिएक्शन. यू कैन सी यहाँ पे हमने क्या किया था? फिनाइल हाइड्रोजीन को कैसे ऐड किया था? अक्रॉस दिस कार्बोनिल ग्रुप. Now also we have this carbonyl group. You can see this is carbon is electropositive and oxygen is electronegative. There is a nitrogen with the lone pair of electron, so that will attack carbon and proton will be given to the oxygen. So this is my again addition product. But in the second step, similar, you can see here this addition product will undergo loss of water molecule. So OH carbon से जाएगा और nitrogen से जाएगा H. So when this will be lost, I will get this double bond here. So water molecule is lost and I'm getting formation of the another phenyl hydrazone at the second carbon atom. Now the last one, that is your third molecule of phenyl hydrazine. Now if you see this is lone pair over here. You can see here there is a double bond between the carbon and nitrogen, in which the carbon is again electropositive and nitrogen is electronegative. So this time again nitrogen is going to attack to the carbon and proton will be shifted to this NH2. So again I'm getting the addition product. And now finally the addition product will undergo the loss of NH2 from here and OH from here. So what is my byproduct? NH3. And the last, that is double bond is formed. This is your final molecule, that is Osazone formation. Okay, if you see this, what we have done, पहला molecule add किया phenyl hydrazine का, we are getting addition product. This addition product undergoes the loss of water molecule to give phenyl hydrazone. That is undergoing the rearrangement to give the loss of phenyl hydrazine. Same, the next step is repeated. Second molecule of phenyl hydrazine added, we are getting addition product. This addition product undergoes the loss of water molecule to give me formation of this phenyl hydrazone. Third molecule added to give me again addition product, and last addition product is undergoing the loss of ammonia to give me the final Osazone formation. तो रिएक्शन में अगर तुम्हें याद है तो ये इसके साथ हमने क्या लिखा था, एक फिनाइल सॉरी एनिलीन लिखा था एज अ बाई प्रोडक्ट, प्लस हमने अमोनिया लिखा था, प्लस हमने वाटर लिखा था. सो दिस इज योर ओवरऑल रिएक्शन. ओके, मैकेनिज्म में कुछ डाउट है? मैकेनिज्म में कुछ डाउट है किसी को? ठीक है, अगर तुम देखोगे फिनाइल हाइड्रोजीन के साथ हमेशा पहले एक एडिशन प्रोडक्ट बनेगा, फिर वाटर मॉलिक्यूल एलिमिनेट होगा. ओके, एंड द डबल बॉन्ड विल बी क्रिएटेड बिटवीन द कार्बन एंड नाइट्रोजन.
मैम ये सेकंड स्टेप रिपीट कीजिए ना.
कौन सा वाला?
ये अमोनिया वाला.
ये अमोनिया वाले में कैसे है देखो, पहले केस में कैसा था, तुम्हारे पास कार्बोनिल ग्रुप था, राइट। अब तुम्हारे पास कार्बोनिल ग्रुप नहीं है, अभी तुम्हारे पास क्या है, सी डबल बॉन्ड NH है, ठीक है। तो पहले केस में क्या हुआ, इसको तुमने क्या दिया, when the carbonyl was reduced, what has happened, this is getting that NH and this was becoming OH, right। इसको एक प्रोटॉन मिलेगा और इसको ये पार्ट मिलेगा। यहाँ पे भी एडिशन जब होगा तो कैसे होगा, कार्बन को क्या मिलेगा, NH एंड इसको क्या मिलेगा, प्रोटॉन, तो ये क्या बन जाएगा, NH2। ओके, फिर तुमने क्या किया, इन दोनों में से वाटर निकाला, कैसे वाटर निकाला, कार्बन विल लूज OH and this will lose H, so that the carbon and nitrogen will have double bond between them। अब हमने क्या किया, हमने वही किया, बट सिर्फ क्या किया, यहां से निकाला NH2 और यहां से निकाला H, so that they will have double bond in between them and there is a loss of ammonia। क्लियर?
यस मैम।
ओके, एडिशन वही है, सिर्फ वहां पे कार्बोनिल की जगह पे तुम्हारे पास सी डबल बॉन्ड NH ग्रुप है, ठीक है। So let us go for now actual practical part, how we are going to do the reaction। First of all, what are the different apparatus required for the reaction? You need a test tube. We are going to carry out this reaction in the test tube itself. We need a funnel for the filtration, watch glass, beaker, stand, wire gauze, all this apparatus required। The chemical part, first we need glucose, we need glacial acetic acid, acidic medium चाहिए reaction के लिए, phenyl hydrazine we are going to use, and then we are going to use ethyl alcohol for the recrystallization process। Okay, so let us start with the experiment. Now first thing that we are going to do, we are going to weigh the starting material, glucose, solid compound is there, so we are going to weigh that compound। So keep the paper on the balance, of course paper has some weight, तो उसको balance कैसे करोगे,
टीयर बटन दबा के।
टेयर बटन दबा के, जैसे टेयर
टेयर
बटन
बटन।
दबाओगे तो वहां पे 0 आ जाएगा, राइट। देन विद द हेल्प ऑफ स्पैचुला take out the glucose, sorry, with the help of spatula take out the glucose and just weigh। We are going to take 0.5 gram of the glucose, okay। It may happen you may not have the exact 0.5 gram, okay, plus minus चलेगा, ओके okay? तो तुम वहां पे एग्जैक्टली तुम 0.505 भी ले सकते हो या थोड़ा कम भी ले सकते हो, एग्जैक्टली 0.5 करने तक वहां पे बैलेंस पे वे मत करते रहना, ठीक है। सो वी आर गोइंग टू टेक 0.5 ग्राम ऑफ द ग्लूकोज। नाउ वंस दिस इज डन, take this glucose which you have weighed and transfer it to the test tube, okay। So the glucose 0.5 gram which we have weighed, that is transferred to the test tube। now we're going to dissolve this in water. So around 1 ml of water you will be adding to the glucose। Now glucose is the carbohydrate, that is sugar, it is water soluble। So जैसे ही टेस्ट ट्यूब को तुम स्टर करोगे, शेक करोगे, the glucose will get dissolved। So what we have done, 0.5 gram of glucose we have taken in the test tube, and in that we have added approximately 1 ml, minimum amount of water you take and try to dissolve the carbohydrate। it may happen 1 ml में नहीं हो रहा है तो थोड़ा और एडिशन कर लो, बट ज्यादा वाटर ऐड मत करना इसमें, ठीक है। तो ग्लूकोज यहाँ पे डिसॉल्व हो गया। now the next thing is the glacial acetic acid। There are two other chemicals, the first was glucose that we have already weighed, that is 0.5 gram we have taken। now other two chemicals, one is the glacial acetic acid and second is phenyl hydrazine। so both these chemicals we will keep it in the burette, okay। so what you are supposed to do, take your test tube and take out around 2 to 3 ml of glacial acetic acid।
मैम
now this test tube, हाँ,
मैम एसिटिक एसिड में और ग्लेशियल एसिटिक एसिड में क्या डिफरेंस है मैम? ग्लेशियल वर्ड क्यों यूज हुआ है?
ग्लेशियल एसिटिक एसिड, ग्लेशियल का मतलब पता है एसिटिक एसिड का, जब तुम एसिटिक एसिड को तुम कूल करते हो ना तो तुम्हें उसके क्रिस्टल्स मिलते हैं, दे लुक लाइक ग्लेशियर, दैट्स व्हाई इट इज कॉल्ड एज ग्लेशियल एसिटिक एसिड एंड इट्स अ कॉन्सेंट्रेटेड एसिटिक एसिड, ओके। नॉर्मल जो तुम्हारा एसिटिक एसिड होता है वो डाइल्यूटेड भी होता है, वाटर भी होता है उसमें। glacial acetic acid is your concentrated acidic acid and it's called as glacial acetic acid because on cooling it gives you crystals which look like glacier। आइस जैसे क्रिस्टल्स दिखते हैं उसके, इसके लिए उसको ग्लेशियल एसिटिक एसिड बोला जाता है। ठीक है, तो अभी हमने
Yes.
क्या किया, 0.5 ग्राम ग्लूकोज लिया, we have dissolved it in 1 ml of water and we have added around 2 to 3 ml of glacial acetic acid. Now the next thing, the next reagent is phenyl hydrazine. You will be adding 1 ml of phenyl hydrazine to your test tube. Phenyl hydrazine generally ऐसे brown color का होता है, yellowish brown color का होता है, जैसे तुम इसमें test tube में add कर दोगे, your solution will turn to this yellowish color. Okay, so what is now test tube is containing, it is containing 0.5 gram of glucose dissolved in 1 ml of water containing the glacial acetic acid to make the solution acidic in nature, and that is a weak acid we have used for the reaction. And then we have added phenyl hydrazine, 1 ml हमने add किया. Now this solution we are going to heat it in the water bath. So water bath का arrangement करना है. So you will make this setup, burner, stand, wire gauze, and then we will keep the water bath on the top of it. I'll just shift it here. Okay. And then you will keep the test tube. Then we will keep this test tube in the water bath. And we are going to continue the heating. As you'll continue the heating, can you see there is a yellow color solid generation or solid will start forming in the test tube. Okay, till this yellow color solid formation is complete, you're supposed to heat this test tube. It will take approximately 15 to 20 minutes. So 15 to 20 minutes you're going to boil this, like keep this test tube in the water bath and continue heating till you get this kind of yellow color solid. This yellow color solid is your Osazone formation. Phenyl hydrazine, which we have added, it's reacting in the acidic medium with the glucose and it is converted into glucose Osazone. The conformation of glucose Osazone is we will get the yellow color solid generation like this when we will heat this test tube in the water bath. Approximate time is 15 to 20 minutes. Okay. Once this is done, take out the test tube from the beaker, and then the next part is we are going to do the filtration. So let it come little bit, you can say come to the room temperature or little bit warm, let it come to the like cool down little bit that test tube, and then do the filtration. Now filtration kaise karoge, funnel hai, filter paper ka cone bana ke that you will put it on the funnel and then keep something beaker or something to collect that mother liquor and filter the solution. So as you'll filter the solution, the solid that is Osazone will be obtained as a filter, you can say in the filter part. So this particular solid you will transfer to the watch glass. We are going to dry this solid. Last time in the experiment also I told you we are going to take the watch glass and I'm going to transfer that solid to the watch glass. Before I transfer the solid to the watch glass, you can weigh that watch glass. Okay, this watch glass should be dry, it should be clean, and it should be empty. Right now everyone note down this empty watch glass weight, how much it is, 1.708 gram. Have you noted down?
Yes,
Okay,
ma'am.
this is a weight of the
Yes,
empty
ma'am.
watch glass. Now I will transfer the solid material to the watch glass. Okay, and now we are going to do the drying of this. Osazone has the higher melting points and therefore we can directly dry them on the water bath. So regular arrangement, you do water bath and keep the watch glass on the beaker and let it dry completely. Those lumps which are formed, you can break them with the spatula so the drying process will be faster. Okay, and once this is done, what is the next part? What we do? Product is formed, it's dried, and now
We
We pull it and wait.
Add alcohol.
right, we will wait, right? So clean that watch glass because it may have some what, like you have kept it on the beaker, so it may have the water droplets which are deposited. So clean it, dry it, and then directly you can weigh it. So note down the weight, everyone, 2.214. So what is the weight of the compound? You have the weight of the empty watch glass, right? And you have the weight of the watch glass with the compound.
0.506.
0.506. What is this? What should I call
Yes,
this
ma'am.
amount as?
Weight of the product.
Weight of compound.
Weight of the product. What is another name? Which yield is this?
Practical
Practical
yield.
yield.
This is
Practical
practical yield. So your practical
Practical yield.
yield is 0.506. Everyone has noted down this practical yield? Okay. So let us go for the next part, that is calculation. So for the theoretical part, you need this reaction, right? So what is my starting material? My starting material is glucose, and I have converted into glucose osazone, right? So first thing, we are going to see the mass relationship between the glucose and the glucose osazone. Okay, we are not going to see the mass relationship with the phenyl hydrazine because that we are using it in excess. Okay, so we are going to find out the mass relationship between glucose and the osazone of glucose. So first of all, everyone, what is the molecular formula of the glucose?
C6H12O6.
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 Can you tell me the molecular weight? Calculate karo. Carbon it's 12, hydrogen 1, and oxygen 16.
180.
180 grams.
Absolutely right. So this is 180 gram per mole. That is the molecular weight of the glucose. Can you calculate? Can you just find out what is the formula of glucose osazone? How many carbon are there?
C
Check.
C6.
C6 है? Check
H12.
करो.
No, ma'am. C18.
C
18.
18. Everyone, are you getting the same answer? C18 है, सबने चेक किया?
Yes, ma'am.
वहां पे 2 फिनाइल ग्रुप है ना?
तो उसके
So there
12
are
हुए ना?
6. हाँ, वो 12 हो गए और ये 6 ऑलरेडी है, राइट? C18. हाइड्रोजन कितने हैं?
Ma'am, C18, H22, and
H22
O4.
N4O4.
O4.
N4O
O4.
O4.
O4. Okay. So now find out molecular weight.
It's 358, ma'am.
358. बाकी सबका क्या
Yes,
आंसर
ma'am.
आ रहा है देखेंगे.
358.
Yes, सबको मिल रहा आंसर. ठीक है. So now I've started with 180 gram of glucose. That is molecular weight of one glucose is corresponding to 358 gram of the glucose osazone. हमने कितने ग्राम से स्टार्ट किया एक्सपेरिमेंट?
0.5.
0.5 ग्राम हमने ग्लूकोज वे किया था, राइट? सो उसका कितना आएगा? सो 0.5 multiplied by 358 divided by 180. Tell me the answer.
Pardon, ma'am.
What happened? You didn't.
0.99.
0.99.
Yes, ma'am. 0.99.
0.99 gram. Okay, so 180 gram corresponds to 358, right? Mass relationship, you can see this is 1:1 ratio. So 180 gram corresponds to 358 grams of the glucose osazone. Therefore 0.5 gram cross multiplication, 0.5 into 358 divided by 180, so it's giving me 0.99 gram, right? Now the next part, what we calculate the percentage yield. What was the practical yield? कितना मिला था?
0.506.
0.506, and this is 0.99 theoretical yield into 100. करो calculation.
51.11.
56.
51.11. So this is your practical, sorry, percentage yield of this experiment. Okay, calculation समझा? कुछ doubts है calculation में?
No, ma'am.
Okay, calculation तो अभी समझ में आ जाना चाहिए. This is like now 4th experiment we are doing, and in all the experiments we need to see what mass relationship we can take it from the organic reaction. हमें balance organic reaction चाहिए. उससे ही हम एक मास रिलेशनशिप बनाएंगे एंड फ्रॉम दैट वी कैन कैलकुलेट द थियोरेटिकल यील्ड. प्रैक्टिकल यील्ड वी डायरेक्टली गेट इट थ्रू द एक्सपेरिमेंट एंड देन थ्रू दैट वी कैन कैलकुलेट द परसेंटेज यील्ड. ओके, नेक्स्ट पार्ट क्या है एक्सपेरिमेंट का?
Recrystallization.
रिक्रिस्टलाइजेशन. सो अब
Crystallization using
नेक्स्ट पार्ट जो
solvent.
है वो हम रिक्रिस्टलाइजेशन करेंगे. सो फॉर द रिक्रिस्टलाइजेशन अगेन you will take that solid which is formed, Osazone, which we have formed, and here I'm going to add minimum amount of alcohol. I've written though it is 3 to 4 ml, but minimum amount of alcohol you add. And in this solvent, this compound will be insoluble at the room temperature, but it will be soluble on heating. अब इसको heat कैसे करोगे test tube को? डायरेक्ट हीट करोगे फ्लेम पे?
नहीं, वो
No,
फ्लेम पर
नहीं,
no, ma'am, boy.
Water bath, ma'am.
water bath पे करेंगे. Why water bath? Because we have used ethyl alcohol as a solvent this time, right? So we need a water bath. Boil करो, and जैसे ही boil करोगे, what is expected? The solid will dissolve. You can see now that yellow compound has dissolved completely. What is the next part? What we generally do? This solution, filtration. In the hot
Filtration.
condition only?
यस मैम.
No, ma'am.
Yes.
Yes, ma'am.
Yes. हॉट कंडीशन में कैसे करते हैं फिल्टर? फनल पे क्या रखोगे?
Filter
Cotton.
Cotton.
कॉटन रखते
Cotton.
हैं.
Cotton is the
कॉटन
mark.
रखते हैं. इससे हम फिल्टर करेंगे. क्यों करते हैं फिल्टर कॉटन से?
Impurities निकालने के लिए.
Which kind of
Insoluble
impurities?
impurities.
Water insoluble.
Insoluble.
Sorry, the solvent insoluble impurities are removed in this reaction. Okay, and then I will allow this solution to cool. As it will cool, slowly the crystals will come out. Okay, these are yellow crystals, and these have a very characteristic shape. In fact, sometimes from the shape of these crystals also they identify which was the given sugar. अब क्या करोगे? Remove that cotton and place now filter paper. And now this test tube which is having the crystal, that we will filter it through this filter paper so that we will get the crystals. Okay, and the next part is taking the melting point. I hope no one is having doubt in taking melting point now, though we are taking theoretical, but you have taken that melting point many times in the first year, right? So everyone knows how to take melting point, right?
Yes, ma'am.
Yes ma'am.
Okay. So
ma'am.
this is again the fourth experiment we have completed, that is Osazone formation. Any sugar can be given कोई भी शुगर हो सकता है, उस शुगर का तुम्हें ओसाजोन फॉर्मेशन कर. ओके, then last part, how will you write the experiment? Everyone knows now. Write down the entire experiment. First you will write the title, then you will write the reaction, the requirements, whatever the procedure, the way you are writing the regular format. This is your experiment number 4. That's why your file name should be your digit, that is your roll number followed by O4. Keep your this PDF file and ready for the, and also for the Viva questions. We will post the PDF file and the Viva question link tomorrow. Okay, is there any doubt in the experiment
What is the melting point of Osazone?
that you need to find?
Okay,
Ma'am,
ma'am.
can you show the second slide of calculation?
Yeah, I'll just skip from here. This part you want? Do you want this step or this step? Which slide you want?
Yes, ma'am. This one. This one.
This one. Okay, so
Thank
in
you.
this what we have done, we have calculated the percentage yield. So percentage yield के लिए practical yield हमने already calculate किया था ना? Practical yield कितना था? 0.506, and this was
Yes, ma'am.
theoretical yield which we calculated was 0.99 multiplied by 100. इसका कितना मिला था आंसर? Something 51.11. Okay, experiment समझ में आया सबको?
Yes, ma'am.
If you see 0.5
Yes,
ग्राम
ma'am.
हमने
Yes,
ग्लूकोज वे किया था. फिनाइल हाइड्रोजीन एंड एसिटिक एसिड जो है वो हमने ब्यूरेट में से निकाला है. फिनाइल हाइड्रोजीन we have taken 1 ml and acetic acid around 2 to 3 ml, and continue heating in the water bath till you get this yellow color solid generation. Around 15 to 20 minutes test tube ko water bath mein rakhna hai till you get this yellow solid. And once you get this yellow solid, we have to filter this and then keep it on the watch glass and then do the drying of that on the water bath. Once it is dried, we are supposed to weigh the compound. Okay, clear? Is there any doubt now?
Ma'am,
Ma'am, I
the
have one
submission
question.
format for last experiment was the whole roll number, experiment number 3, and full name. And inside and in the video it was written XXX03.
I didn't get you. What you said?
Ma'am, the thing is the file name we have to do. For the
Hmm.
last experiment, it was given like for two types you have to name the file. One XXX03 and one whole roll number, experiment and full name.
Okay, maybe Saurabh sir must have given you that format, na? So the way he has told you, you can write in that way.
Okay, ma'am.
Ma'am, I
Okay.
have one question.
Ma'am, mechanism part also.
Huh? What? I didn't get you. What you said?
Ma'am,
Can you
we
repeat
have to
your
write
query?
Ma'am, we have to write mechanism part also.
Yes, you are supposed to write the mechanism also. See, all this writing part, whatever you are submitting, it's kind of like your journal, and your journal has marks. ओके, तो जो भी तुम हमें सबमिट कर रहे हो ना ऑनलाइन, एक एक एक्सपेरिमेंट लिख के, इट इज योर सॉफ्ट कॉपी वर्जन ऑफ योर जर्नल. Okay, and that has marks. So whatever we are said, what this is the format, please follow that format. You are supposed to write everything whatever is discussed. Mechanism तो लिखना ही है सारे एक्सपेरिमेंट का.
Ma'am, why we calculate practical yield before the process of recrystallization and not after actual calculation of melting point of actual compound?
Actually speaking, if you talk about organic derivatives, generally after crystallization, you are supposed to calculate the practical yield. Okay. This is format we have kept in just because sometimes what happens, students, they don't have a working or a practical hand properly. Because of that, they lost their compounds. और end में कुछ नहीं बचता है, and you don't get marks for that. If you see, the practical yield actually is supposed to be calculated after recrystallization only. Okay, so for saving time, since you have the limited time for your practical exam also, so what we do, we tell you to first dry that compound, and very small amount we tell you to crystallize. Okay, as you'll go in your higher studies, higher level studies, आगे जाओगे तो अब तुम्हें पहले रिक्रिस्टलाइज ही करना है, और रिक्रिस्टलाइज प्रोडक्ट का ही प्रैक्टिकल यील्ड कैलकुलेट करना है. ओके, राइट नाउ आवर एम इज जस्ट टू प्रिपेयर द डेरिवेटिव्स, इसलिए हम क्या कर रहे हैं, उसका प्रोडक्ट का हम यील्ड कैलकुलेट कर रहे हैं. बट प्रैक्टिकली स्पीकिंग जो प्योर होके आ रहा है उसी का यील्ड डिटरमाइन करना चाहिए. ओके, तो टाइम सेव करने के लिए
Ma'am, then it
जस्ट,
will be much less then.
I'm not getting. Actually, your voice is too low. I can't hear you at all. Can you repeat it?
Ma'am,
What you
then
said?
in that case, the percentage yield will be quite less if we are calculating it after actual process of recrystallization, right?
Yes, but for that, if your working hand is good, you will get even the good yield even after the recrystallization. And you need to take a lot of care to save your product. अब तुम क्या करते हो, कभी कभी फिल्टर पेपर से निकाल देते हो प्रोडक्ट, राइट, वॉच ग्लास पे. तुम क्या करते हो, जितना आता है वो लेते हो, बाकी सब फेंक देते हो. You're not doing your experiment that much carefully कि पूरा compound आना चाहिए. Are you taking that much precaution during experiments? No. We just take like lightly हम experiments करते हैं, but actual experiments जो design किए जाते हैं ना, वो ऐसे ही होते हैं कि तुम्हें इतना precaution लेके तुम्हारा working hand इतना अच्छा होना चाहिए कि तुम्हें yield अच्छा मिलना चाहिए वहां पे. Because if the steps are like, if the procedure is reported and everything, definitely you are supposed to get good yields in the reaction. Okay,
Okay.
सो प्रैक्टिकल यील्ड अभी फिलहाल तो हम बिफोर क्रिस्टलाइजेशन ही कर रहे हैं फॉर द टाइम सेव करने के लिए. वी जस्ट टेल यू टू रिक्रिस्टलाइज स्मॉल अमाउंट ऑफ प्रोडक्ट. In the, if you go in TY, maybe they ask you to recrystallize the entire compound and then you are supposed to determine the practical yield. And don't worry, ऐसा कुछ नहीं होता है, product मिलता है वहां पे भी. Yes, any other doubt?
Ma'am, I have a question. How our exam will be conducted, practical exam?
Till now, it is decided, first of all, whatever the practical experiments you are submitting to us, written format, that had certain marks, okay? And then Viva exam will be conducted in the quiz form.
Okay, ma'am. Thank you.
Online quiz will be conducted for the Viva, and this soft copy version of your journal that has marks. And that's why please submit your all the assignments immediately after completing the experiment. Write down the entire experiment, including everything, mechanism, everything you're supposed to write and submit, because we have kept some weightage for your journal and Viva. Because practically तो possible है ही नहीं ना, तुम कॉलेज में आके एक्सपेरिमेंट करोगे, तो जो भी एग्जाम होगा प्रैक्टिकल का वो भी ऑनलाइन ही होगा.
तो
Okay,
मैम
ma'am.
अभी कंफर्म है कि कॉलेज नहीं ओपन हो रहा है?
कॉलेज क्या रीओपन?
नहीं हो रहा है अभी फिलहाल दिसंबर तक, टिल दिसंबर और जनवरी.
अभी तक see we have to follow all the government's rules and regulation. There is no news na till now the college and schools are open.
नो मैम.
So wait,
Schools
तो
have
वो अभी वो I cannot give you assurance for the December right now. If government says you have to come in December, you have to come. There is no option for that. So we are following all the rules and regulation of the government. हाँ, schools का क्या हुआ? You're not audible. Okay, is there a query regarding the experiment?
Ma'am, in mechanism, we have to means explain the mechanism also along with drawing the structures.
No. Just write the mechanism. Only the thing mentioned that arrows and everything, na, which I've shown you, how the electron is attacking, mention that. So you will get this right now on the screen. It's not visible. We are going to share the recording also na, with you. So watch that video again, see the mechanism and write down only the reaction part. No explanation is required.
Okay, ma'am.
Okay. You can keep the explanation writing with you for your understanding, but no need to write it in the mechanism. Okay. Is there any doubt regarding the experiment still?
No, ma'am.
Okay. So can we conclude, Saurabh sir? Do you have any doubt, students?
Yes, ma'am.
No, ma'am.